Hi class, for these set of problems we're going to be using some of these formulas, and also maybe more than one formula applies as we simplified each expression. So let's take a look at problem one. Now all they want us to do is simplify, and simplify as you're multiplying polynomials means to express the polynomial as a single one. For example, on this particular one, you're multiplying x and x squared, so you could simply just do x times technically x times x, which actually represents x to the second. And if you count how many x's you're multiplying a total of 3 x's. So this is one way to approach the problem. If we were to use the formulas, notice that the first formula applies here because you technically have x to the first power times an x to the second power. This is equal to, and in the formula, as long as the bases are the same and you're multiplying, you're adding the exponent. So this will be x to the 1 plus 2, which will give us x to the third power. So for these problems, you may do the expansion or use the formulas. I'll try to use the formulas for the majority of them, but as I mentioned earlier, some of these may apply, and there could be multiple formulas that you could use on any specific problem. Let's move on to problem B. And in B, I'm just going to use the formula. So this is equivalent to x to the first power times an x to the 10th, or x to the 1 plus 10. And this is going to give us a x to the actual 11. That's it for B. We're applying the same formula from above. Let's take a look at C. Now on formula C, I'm going to be applying the power property, and that's going to be this one, which means if you have a base and an exponent raised to another exponent, you're technically multiplying the exponents. So on C, we're just going to be expressing it as this is x to the 3 times 9, or x to the 27. That's it for this one. Let's move on to problem D. Okay, let's take a look at problem D. And problem D, we're going to do an extension of the previous formula. Now, notice that the formula, what it does is, if you technically have a value raised to an exponent to another exponent, you multiply it. But if you have two values, both of the exponents can multiply. So in this case, it's the third formula from here. So for this one, we're just going to be exponentiating both of the bases. So let me rewrite it. So this is going to be x to the 3 times 9 times y to the 2 times 9. And this is equal to x to the 27 and y to the 18th. That's it for this one. Okay, let's move on to E. Now on E, we do have to be a little bit careful. And what I'm going to do here is I'm going to rewrite it as technically -1 times 8 times A times B to the 5th raised to the 2nd. And then I'm going to exponentiate each of these to the 2nd power. So this is equivalent to a -1 to the 2nd times an h squared times an a squared times a b to the 5 times 2. And then the -1 to the 2nd, it's technically just a 1 times a to the 2nd times a squared times b to the 10th, or 8 squared a squared b to the 10th. And I'm going to box this in as a possible final answer, because technically all the values are already in lowest terms, or they may want us to expand it. So in this case, 64, a to the second, b to the 10th. And that's it for this one. Let's take a look at F. Now, F is similar to the previous one, and let me just, before expanding, extract that -1. So this will be 5 times a -1 times a 2 times a w to the 7th raised to the 3rd power. And in this case, we're just going to be expanding that value. The 5 is on the outside, so you cannot actually multiply it in because of the 3rd power. This one doesn't have a 5 to the 3rd power. So you first exponentiate, then multiply times the 5. So this will be a 5 times a -1 to the 3rd times a 2 to the 3rd and times a w to the 7 times 3. Or 5 and -1 to the 3rd, it's going to be -1 times -1 times -1. So technically this portion is going to be -1 times -1 times -1. Both of these will make a positive, so that would be 1 times a -1 or a -1. So this is going to give us, in fact, a -1 times a 2 to the 3rd and times a w to the 21st. Or -5 times 2 to the 3rd times w to the 21st could be one way to express this one. And let me just multiply the numbers. So this will be -5 times 8 w to the 21st, or -40 w to the 21st. And that's actually it for these set of problems. I'll put the rest of them on another video.